Welcome to Crack It. In this video, we will explore common errors frequently made by we developers during the development of the Spring applications. Everyone encounters mistake, either it is a real life or it is the program, but it's crucial for us to learn how to avoid them. So in this video, let's learn to avoid the mistakes that we do in the Spring framework. And if you find the content helpful, please don't forget to like, share, comment and subscribe to the channel. Okay, we can debate that it's often common to make mistakes, but we need to avoid those mistakes. Why do we need to avoid those mistakes, especially while working in the Spring Boot? It's a complex framework and it provides a lot to us. We need to utilize the Spring, all the functionalities that the framework provides in a very good way instead of we doing mistakes. So we need to avoid the mistakes, and the mistakes that we do may affect our functionality, performance and scalability. Suppose say I've deployed my application to the production and I'm like getting a feedback that the performance is very bad. So after moving my application to production and then sit analyze why this performance issue is happening, if we write our code properly without doing the following mistakes that I'm going to say in this video, it will be really for us to avoid that situation. So going to production and fixing a production incident is a stressful process, so we need to avoid that thing and we need to make sure that our code is clean and it addresses all the functionality, it is with a good performance, it's scalable, everything we need to ensure. How? By avoiding the mistakes, common mistakes that we do. And also, if we avoid all these mistakes, then our application will be reliable, efficient and secure. So there is a chance that we may leak some information to the outside world. We should not do that. Our application should be efficient, our application should be secure. So whenever you raise a pull request against your main, make sure that you are not doing the following mistakes in your code, just to save your time, your effort and the resources in the long run. The very common problem that developers do is lacking the separation of concerns, which is nothing but dumping the new functionality into existing classes. Suppose, let's assume you have created a code wherein you are exposing your entity, and while reviewing your PR, you got a comment saying that you need to fix this and you need to create a DTO for it. So what you will do, you will just create, you need to create a DTO in a new class instead of you creating a record in the same controller class. So that is not advisable. So dumping the new functionality into the existing classes is not advisable. In my example which I gave, we are going to create a new record as a DTO, which we need to create as a separate class, separate record, but not in the same controller class which you have created. It seems to be a very easy solution for you to create a record there directly, but that is not the case. That is not a that's not a efficient solution. You like, while testing your code or while writing the unit test cases and maintaining your code in a long run will be a really a difficult task. So what is a cleaner code? Cleaner code is separating the concerns into the new class when and where required. Also, this will help to determine where functionality exists just by inspecting the class name. Yes, let's assume you are getting your, like, all your business condition should present in the service layer and not in the controller or the repository layer. If suppose for as a short term solution, if you added your business functionalities to the controller class tomorrow or later someday, if you go check in the service, you will not be able to see that condition in your service class. So it's always a biggest advantage if you separate your concerns in your separate classes. If you find this video helpful, please consider giving it a like. Your likes are meaningful and will contribute to helping this video reaching a wider audience. Please like this video and share it with your friends who are preparing for interviews. To explain this example, I am using the same code that we used for valid versus validated demo. So we have a video which explains the difference between at valid and at validated annotation. So if you want to see that video, I'll provide the link here. You can go through it. I'll also add that link in the description if you want. So we are reusing the same code that we used for valid versus validated. I'll explain what we have here in this code. So we have a controller, and in that controller we have two post mappings, which is nothing but the cracket and the crackets slash step 1. To illustrate at validated annotation, which is nothing but the step level validation, I have added this post mapping, and to validate the entire object, or to illustrate the at valid annotation, we have this post mapping. So the code is straightforward. I can open and I'll show you the service class as well. So in the service class you will be having only one method there, which is to save the cracket object to the cracket repository. So everything is straightforward. Even in the repository we don't have any default methods. It's straightforward. We are just reusing the methods that we have in the JPA repository. So as far as the code wise, it's straightforward. We have a controller, and in the controller we have two post mappings, and we have only one method in the service. And for the entity objects we have added the validations. So we have added the group level validations for the at validated annotation, and we have full validation as well for the at valid annotation. So as an entity level also we have added validations to each and everything we want. So this is the code. So if in that example, if you see, we are exposing our entity class to a outside world. This is also one of the mistakes that we often do. I'll come to this later. So in your PR comment, what you're getting is you are asked to write a DTO for it. So if you create a DTO for it, you need to make sure that your DTO is a different class. If you see here, it is in green color since I have then committed my code and I'm using it. So I have created a record for this cracket DTO, and I am mapping my entity object to this DTO class, and I need to expose this DTO. So for that I need to make sure that my DTO class is in its own package and in its own class. And if you see here, I am mapping it in a controller. Is it a good practice? No, this is also not a good practice. Ideally this mapping method should be in a separate mapping class or in the service layer. It is not a good practice to write this mapping class in the same controller. For your convenience, it should always be present in a separate service layer if it is available, or in a separate mapper class. So what I'm going to do is I'm just going to copy it and I'm going to paste it in the service class. This is a good practice. So what do we need to do? We need to write our business functionalities in our service class and not in the controller class. So with this our problem gets solved. So next common mistake is, just as I just showed in the example, leaking the internals. So in the example we are leaking our entity class, or we are exposing our entity class, which is nothing but a database structure, to the API endpoint. So it is not at all a good practice to expose the internal structure or the database structure to the API endpoints. That is a very, very bad coding practice. So we need to make sure that we are not leaking any internals. So in this example, we are exposing our entity class or the database structure to this API, which is a wrong practice. So ideally what we need to do, we need to expose our DTOs. So we need to expose our DTOs to the outside world. So we need to create a DTO and we need to expose it. We should not leak our internals to the outside world. It is not a good practice. Next is a follow-up. Use records where necessary. So we previously we used to create the DTO classes like a POJO classes, but we have Java has introduced a very wonderful feature which suits very well with Spring, which is nothing but the records. So in all the places where and all we were creating DTO classes, we can create records in those places. This is like very handy, very helpful, and it avoids a lot of boilerplate code. So use records wherever necessary. Next is using annotation based validation. So it's always very easy to use annotation based validation instead of using multiple if blocks checking the conditions. Let's try to understand this with an example. So here in this example, if you see, we are validating our input request through these annotations. Suppose for this ID, I have an annotation at not null, and for name again I have the same annotation at not null. I'm checking whether the playlist name is not blank, and for the views I have added a minimum condition that this integer value should not be less than 100. So like these I have added all these annotations, and to make this annotations work, I have added the at valid annotation or at validated annotation based on my condition. If I need a step level validation, so I'll go with at validated. If I need to validate the entire object, I'll go with at valid annotation. So if you see here, it's very easy to validate this object. So if my request body sends the view value as 98, it will throw exception saying that the input is wrong. It will send 400 HTTP status code to the user. So it's very easy to validate the input object using the annotations. If suppose assume if I don't have this annotation here, then what do I need to do? I need to go inside this. I need to check whether if this object dot I need to get views, and I need to check whether this views is greater than 100. If not, please throw exception. If it is less than or equal to 100, please throw exception. So I need to write a if block for each and every condition of my object, since I have that, like I have implemented conditions for all these. So I need to do in that way. So it's always better to use the annotations for the validations instead of adding these if blocks. Next common mistake is forgetting profiling. So profiling is a very important and a wonderful feature of Spring Boot framework. So we need to make sure that we use profiles in our application. Suppose let's assume that I have in memory database say H2 for local development, and I have Postgres for production, and I didn't use profiling in my application, and I need to do some testing in my local environment wherein I forgot to change the local credentials and I have changed something. So what will happen? What will happen if I accidentally make changes to the production configurations? That will be very, very bad. So it's always good to use profiling in our application. So instead of manually replacing various configuration entries and switching from testing to a production application, a more efficient way would be to employ or use profiling in our application. I'll show an example on how to do profiling. It is always better to provide the dev related properties, all the local related properties in application dev.properties. So it will, and we need to provide this profile as active by default. So by default, it will always pick the dev profile. So if you do any code changes in your local, you are sure that you are not making changes to your production configuration database or production config details. Always you are making changes to your application dev.properties, which means you are making changes to your dev config file or the local config file, and you can override this configuration in your higher environment using you can use -d spring profile active is equal to prod while deploying it to a production application. So it's very simple. Or what you can do is you can create one more file here, application-prod.properties, and you can provide all the prod related information over there. That is a very good practice than overriding the specific config while deploying it to production. So it's always best to use profile in your application. Don't forget to use profiling. Next mistake we commonly do is like we fail to embrace the dependency injection, or we fail to accept the dependency injection. So using dependency injection in a project has a lot of benefits. So it will just wire all the objects that we require just by scanning the configuration classes, and it is useful for decoupling relationships. That's what we want, right? If we are developing a microservices application, or if we are developing any application, decoupling is a main thing we want. So it is useful for decoupling as well, and even in testing, if we have decoupled relationships, it's easy for to auto aware our dependencies through mockitos, just by mocks. But if it has coupling relationships, that will be difficult. So I'll explain it through code. It will be better, easier for you to understand. So we have a cracked service variable here, and in our constructor we are initializing this cracked service using the new keyword. This is not a best practice to do to create an object, I would say. This is, in this we are creating a tight coupling, so it is always a good practice to decouple our applications easily. So what we need to do, we need to use constructor based injection that Spring provides. This dependency injection is very easy. There's no need for us to create a new object for the service. Instead, if our service is annotated, if our service is annotated with at service, yes, Spring will create that object and it will put it in the class path, and if we use constructor based injection, it will pick up that object and it will place here. Also, since we use Spring's dependency injection, it's easy for us to mock this object, since this doesn't has any coupling in it. It's very simple. So it's always good to use the dependency injections. It's always a good practice to use dependency injection. So next common mistake that we do is proper not handling our exceptions gracefully. It is always important to handle our exceptions gracefully with the understandable error messages or the easy error messages for the clients, instead of sending them the stack trace. So it's very important to handle the exceptions gracefully in application. Let's see in IntelliJ how we can do that. So this is the post mapping for my cracked class, and I have handled my exceptions really well. You can see that I have added at valid annotation here, so it will check for each and every value. So if suppose I have a wrong ID, if I'm sending a null value to my ID, I will get a message saying that ID is mandatory. And if suppose I have a name, I didn't pass the name, I will get the message as name is mandatory. So it is always essential to provide a user friendly messages to the client, and we need to handle this exception gracefully. How are we handling? So if suppose, if you see here in my exception handler, what did I do? I have created a at rest controller advice, and I have created my exception handler. In that I am handling this method argument not valid exception. So anything in the request body, if it is not satisfied this condition, which condition? The conditions that we have provided in our entity. If it is not satisfying this condition, then it will go in the method argument not valid exception, and it will throw HTTP status 400. So I am handling this exception properly here, and I am displaying the error messages accordingly. So if suppose like for the multiple fields it is failing, see, I am iterating each and every field, and I am displaying the error messages accordingly. So it is always best practice to handle our exceptions properly. If not, it will lead to a waste of time for we developers while sitting analyzing later after the production. So this is one of the common mistakes that we do, and we should avoid it. So next is version conflicts. So we will obviously, if we are creating a Spring application or a Spring Boot application, we will add all our dependencies in our pom.xml file if we add Maven. So if we add our dependencies, we need to make sure that we are adding a proper version to the dependencies. It is because there may be a chance that a certain version of dependency is not compatible with another dependencies version, and that's just because of the version conflicts. And if you're not aware of that, and if you start running application, your code will throw an error. Obviously that will be due to the incompatible jars. So what do you need to do? You need to know which specific version of the specific jar is supporting the other version. We need to make sure that. So one of our developers had faced this issue when we are migrating our Spring Boot project from 2.7 to 3. It was the JPA version that version was wrong in her pom.xml file, and it took like 3 days to resolve that issue for her, because she doesn't know that there is something called version conflict. And for her, what was happening was it was not able to read the repository file. Since that is a JPA dependency issue, she was getting that, and she was checking all the possible ways which and all is failing. She makes sure that at repository annotation is there. Then she was like very blank, and she was not able to identify it. So it is always good to know which specific dependency, which specific, suppose if you're using 3, you need to make sure that the spring, which specific version of JPA is okay for to use to spring 3, which my for developers was missing. So we need to make sure that if we specifically if we are migrating your project from older version to new version, so we need to avoid the version conflicts. This is one of a very common mistakes that we developers do. Thanks for watching Crack It. Please do like, share, comment and subscribe if you like the content. Your likes are meaningful and helps this video to reach to a wider audience. Stay tuned for the updates.